Let me know when. Okay, they're going.
Go.
Yeah, so hey everyone, welcome to kind of our last Arvade meetup of the year. Welcome to, well, I imagine we have some first comers, people first time being here, and we have we got a lot of familiar faces, familiar names. So welcome to all of the old timers. It's been a great year. Like Sam said, it's been an interesting experience to kind of see how this has changed over the last year with the progression from starting in person about a year ago. And we had some great meetings at the EPON offices there. And then we had to transition in March to online, and we've kind of kept it going. So it's been a great year, and I hope we can keep it up next year. We are looking for speakers for next year, so I'll just put a plug in for that. So if you're interested in speaking on any topic really that related to data or data engineering, just talk to one of the organizers, me or Sam, Brandon, or Julia, and just let us know. So without, I'll go ahead and get started. I got a good number of slides here, and I'm probably going to go fairly fast. I will hopefully have time for some questions at the end, but if we run out of time for questions, just reach out to me on Slack or LinkedIn, one of the other channels. So let's just go ahead and dive in. So agenda for today, I'm going to talk about what is a data lake, cover some architecture and design principles, talk about governance and support. So a lot of topics there, and I'll probably have to kind of fly through those, honestly, because there's so many. I hope to talk about some lessons learned and just kind of some real experiences from having done this a few times, and then get into a few of what's coming up, in the future, what's next. So a little bit about me. Like Sam said, I've been doing development for a lot of years. Been at CarMax since 2019. Before that, I worked with CapTech for a number of years as a consultant. And then before that, I was at Capital One for many, many years, doing lots of different roles, mostly data related. I've worked on 3 different data lake implementations at 3 different companies and using 3 different technology stacks. So I felt like that was kind of a good number to give a talk like this, because I can kind of draw on those various experiences and come up with some good lessons learned. A couple of fun facts. I do karate. I actually been doing that with my son for many years. I have a black belt, and also love music, play guitar. So let's just dive into the first topic, which is what is a data lake. But before we go there, I want to just kind of talk about a little bit of history. So just to understand kind of where data lakes came from, and sort of the data warehouse concept, which was sort of the predecessor to data lakes. So going back to kind of the 1990s, really 1980s, I think this started, but took off in the 90s, and then up into the mid 2000s, we had the concepts of the data warehouse. So these are, I call these metaphors, really. The data warehouse is just a metaphor that's interesting and helpful for understanding how to deal with large data stores. So that was popularized. There were 2 main kind of I guess lead thought leaders in that space, Ralph Kemble and Bill Inman, both having kind of different approaches. These were all based kind of around the use of what single processor machines like SMP database systems. Oracle is one of the most popular, SQL Server, Sybase, et cetera. And then the proliferation of ETL tools, there was a whole bunch of those as well. And then eventually it kind of led to the growth of MPP database systems like Teradata. So this is kind of just just a broad brush, 2-second historical. But I lived through a lot of that, and that was kind of where big data came from. It's actually still relevant. There's still a lot of relevant things in there, and a lot of these companies are still going strong. So I'm not discounting that by any means, but that was kind of the background that led to kind of this next generation of tools, which I have called here open source big data and cloud. And so in the early 2000s, there were actually two papers that came out of Google that was kind of foundational for the big data concepts. That was the Google file system and the Google MapReduce papers. And you can actually download those and read those if you're interested. And then a couple guys took those papers and actually developed Hadoop, which was the open source, taking those ideas and then implementing them in an open source way. And foundationally, that was kind of what kickstarted a lot of the big data movement in the 2000s. Companies like Cloudera, Hortonworks, MapR, and a bunch of other ones kind of took the Hadoop open source distribution and packaged it and sold it. And then along came the cloud providers. So AWS, Google, Azure. There's a bunch of other ones obviously as well. Those are the three major ones that I deal with or am familiar with. But and then that kind of the combination of those two kind of was a springboard for a lot of other things, which we'll talk about. Apache Spark was kind of another milestone. So that built on top of the Hadoop work that had been done earlier, and it kind of gave a new life to the whole kind of big data landscape, and a lot more performance really was the key thing that Apache Spark gave. And then Databricks, and then Delta Lake. So I've left out a lot of things, but these are kind of key things that I want to talk about because they're things that are important to the topic today. So I'll talk about Delta Lake some more. Databricks is basically a Spark as a service offering, and that's actually the tool that I've been using in the last project that I've been working on at CarMax. So I'll be talking about some of the concepts that Databricks uses, but a lot of these concepts can be applied to multiple data lake technology stacks that are out there. So what is big data? I couldn't really have a talk on big data on data lakes without talking about this or having a slide like this. So this is kind of the classical definition that was I think originally written by a guy from Gartner, Doug Laney, and he came up with what they call the 3 V's. So essentially it's volume, variety, and velocity. In a nutshell, I just kind of think of big data is massive volumes of data that can't be processed on a single machine in a reasonable amount of time. Now, interestingly enough, that definition is kind of relative. So as machines get bigger and faster, you can do a lot more on a single machine than you could, say, 10 years ago. So the need for, I would say, big data clusters or infrastructure actually is potentially lessened over time as single machines grow. So that's not to discount this, but it is to consider the fact that sometimes you don't really need a big data solution. A laptop with a huge hard drive actually will sometimes outperform a cluster, in Hadoop or Databricks. But that's a sidebar. So what is a data lake? So a data lake this is a definition I think I just lifted from Wikipedia, but it's a system or repository of data stored in its natural raw state format, usually object blobs or files. It's usually a single store of all enterprise data, including raw copies of source system data, transformed data used for tasks such as reporting, visualization, advanced analytics, machine learning. It can also include structured data from relational databases, semi-structured data, and unstructured data. So that's a pretty good definition. I kind of think of it as just a big file system. And that's roughly kind of what it is, in fact. But it's a place to put all your data, and the big differentiator is that it's flexible and allows different types of data. James Dixon, I think the guy who came up with the term originally in a blog post, which is still out there, you can read. And he just says, I think of it as a data mart as a store of bottled water, cleansed and packaged and structured for easy consumption. The data lake is a large body of water in a more natural state. Contents of the data lake stream in from a source to fill the lake. So it's a metaphor, right? So that like the data warehouse was a metaphor that was helpful for understanding, storing large sets of relational data in a database. The data lake is a metaphor for understanding data streaming in and filling up I think a reservoir might be an even more appropriate metaphor name, and I think that was proposed. But reservoir, I guess, is 3 syllables, and lake is 1 syllable, so it's easier to say data lake. So looking at the data warehouse versus the data lake, that's kind of the classical comparison. That's it's interesting to look at the differences. So at data warehouse, the format is typically structured. You have tables and columns basically defined, whereas a data lake can be a variety of things. It can be structured, it can be semi-structured or unstructured. You can literally just have files with binary data that's has no schema at all. Data warehouse is traditionally done. You have to model your data up front. So before you load your data to the data warehouse, you have to declare what your schema is going to be, which is we call schema on write, versus the data lake, which is the term has been popularized as called schema on read. So you can essentially load your data to the data lake, and then theoretically just read it at defining the schema as you read it, and that could be flexible. Relative cost, traditionally data warehouses were fairly expensive and a big investment up front. Data lakes, depending on how you do it, obviously could be expensive as well, especially if you're going to buy hardware and install it. But increasingly with the cloud, it becomes cheaper and cheaper to do that, and storage is increasingly cheap. Flexibility. So data warehouse projects are typically fairly slow. I mean, relatively slow, like to populate new data stores or subject areas, can take months of development time usually. Whereas a data lake, because of the nature of the fact that it's schema on read, it's a little more flexible and can be more more agile. Performance. So this is kind of where it gets into maybe the data warehouse is slightly better. The data warehouse is really tuned for fast query responses, where data lakes are general purpose access and slower. Data quality, also the data warehouse will be focused on high quality curated data, whereas the data lake will typically be lower quality or raw data that hasn't been curated. So it's a broader brush. Target users, the data warehouse is really targeted, I think, towards business analysts or data analysts, obviously all kinds of users, but whereas the data lake, traditionally, or so far, I think it's been targeted mostly towards data science, although that's changing as well. So I think that's a generalization, but I'd say that's mostly true. And then typical use cases, obviously data warehouse, you can do lots of things with it, but traditionally reporting and visualizations were 2 of the main things, whereas data lakes are a lot of times used for more things that are related to machine learning or predictive analytics. So again, this is not a hard and fast rule, but it's a generalization. So what is Delta Lake? I mentioned that earlier. That's an important piece of kind of the data lake puzzle now, increasingly so. So this is actually a fairly new technology. It was introduced, I think, 2019. It was created by Databricks. It was open sourced and also given to the Linux Foundation, I believe. And it's essentially a technology layer that's compatible with that Apache Spark, and then adds on top of it some database-like features, including ACID transactions. I think that's probably the biggest thing. And what that does is it effectively kind of turns your lake into a big database. So it has some other features. I guess the other big feature that it adds that we couldn't do very easily before is updates. So traditionally in the Hadoop data lake, as it originally came out, everything was considered to be kind of write once, read many. So you didn't go in and make edits to the data that was already there. It was considered to be kind of immutable. And the Delta Lake design has actually opened up the door to essentially making edits or updates to your data that's in your data lake. So that's a big game changer actually, and a lot of companies are using this now, embracing this even outside of Databricks. So it's an open source technology, and it can be used for, like Microsoft is using it now for Synapse, for instance. Another big thing is really the cloud has changed a lot of things. So I just wanted to kind of throw in a couple points here related to that. So going from premises data centers, where it took like literally, I remember my first data lake project, I think it took months to acquire the hardware and stand it up in the data center. So during those months, there wasn't a whole lot we could do. We were just sitting, waiting. We did stuff on our laptops. But now you can literally scale up a data lake in minutes. So that's just a huge shift. And then the other big thing with that is the decoupling of the compute from the storage. So I trying to understand, like, explain what that means. But in the first iteration of data lakes, and Hadoop in particular, you were essentially bound by what the storage that was directly on the machines that that your cluster had. So it was designed actually literally to have local storage, which in some sense was an optimization. At that time, it worked really well, but it also meant that you were essentially had a fixed sized storage to deal with in your cluster. And so that was a hard limit. And you had to, in order to increase your storage, you had to literally add more nodes to your cluster. Now, with the decoupling, and especially in the cloud, you can essentially have your compute, scale out your compute as big or as small as you want, and your storage can remain independent. So the idea is, your storage can just kind of linearly increase over time. It's relatively cheap now, to store data in the cloud. And then your compute can be essentially spun up and spun down on demand. So you're not paying for it if you're not using it. So that's just a huge benefit to going to the cloud. Okay, so I'll stop there for a second. Yeah, I guess because I have so many slides, I'm just going to keep on plowing through. And then if you guys have questions, just keep them or put them in the chat, and hopefully I'll have time to get to them at the end. So I think I'm doing reasonably okay for time, but I'm going to move along. So data lake architectural considerations. I just wanted to throw this up there because if you guys if anybody's thinking about building a data lake, there are a lot of things you need to think about, and that's kind of what the purpose of my talk is what are some of the things you need to think about if you're getting into data lakes, or if you're thinking about building one. And a lot of these are just things that kind of make sense and common sense if you've been doing this for a while. But scalability obviously is a big one. Flexibility, these are all kind of the ILADs, architecture. We used to call them non-functional requirements. Security is a big one. Availability, supportability. There's probably a lot more, but these are kind of some of the key ones to definitely consider. I think security is kind of one of the ones that sometimes gets a little bit overlooked, but data is really the lifeblood of an organization a lot of times, and we want to make sure it's secure. Scalability and flexibility really tie into the ability to have lots and lots of data, and then be able to use it easily. And then availability obviously ties into making sure that you have disaster recovery or kind of be able to recover and keep your system online. And then supportability is kind of one of the things that's obviously that applies to all system development, but I've found from experience that it can be very easy to get into some systems that are developed in such a way that they're very hard to support. So cloud versus on-premises, I think I've already kind of covered this, but in a nutshell, in the cloud, you have flexibility and agility, scalability, they're just kind of all built in. You have the OpEx cost model, so you pay basically for what you use. There's no data center. But you do have lack of control of the data, so you're kind of giving the keys, well, there are options where you can actually keep keys, literally the encryption keys on, in your own control, but the data is not on your computer, it's on somebody else's computer. And then depending on the workload, costs can be actually higher. So that's an interesting equation. But if you have stuff that's running 24/7, at a high volume, sometimes it is cheaper just to keep that on-prem. And some companies do that, but there's lots of trade-offs there that come with that. And so for on-premises, obviously it's kind of the opposite picture: slower time to market, limited scalability. You have capex, capital expenses, so you're paying a lot of stuff up front, but you have full control over your data, and depending on the workload, it could be actually more economical. So anyway, just an interesting thing to analyze. I personally love the cloud, and I would encourage everyone to to go that way if you can. But sometimes there's good reasons to keep it on-prem. So this slide is just basically talking about some of the key components of the data lake architecture to think about. And I just kind of made these up, but it's some of the major things that I've dealt with as we've built the data lakes that I've worked on. So storage is obviously kind of the number one thing. You need to think about what storage, what kind of storage you're going to use, and what technology and so forth. So that's kind of that's the treasure really of the whole thing. The processing engine is also pretty important. So there's different choices there. Like I said, I'm using right now the one I'm working on now. We're using Spark as our main processing engine, and that works really well. Hadoop also works well. There's some others out there, but those are probably the two leading ones. As data lakes mature, we're going to see other ones coming out. Actually, Databricks is working on a new engine right now. That I think it's still in preview mode, but it's kind of something that will run alongside Spark. So yeah, but those are that's a choice that needs to be made. Orchestration is also important. So how are you going to orchestrate your jobs or your applications? There's a lot of choices there as well. In the Azure world, we have Data Factory. Outside of that, we have AWS, I think, has Glue. There's Airflow, open source one. Lots of Uzi is kind of the Hadoop equivalent. So there's lots of choices for that, but that's an important component. And then user access tools, there's a ton of things that could be said there, but essentially we have a variety of different tools that you need to think about. How are you going to give your users access to the data? There's online tools. There's desktop tools as well. You can connect with things like JDBC. So there's some choices that need to be made there. And then finally, data catalog. So that I'll talk more about that. I'll go on to that slide in a few minutes. So data lake environments. This is just a slide basically talking about you need to think about having different environments. This is kind of a no-brainer, but if you're not from a kind of a traditional IT background or that mindset, you may kind of overlook this. So it is really critical and key to have multiple environments and then keep those environments in sync with each other and have some sort of automated process where you're promoting the code or promoting the objects. This is this can be a real pain in the rear, actually, managing these environments. And I'll talk a little bit more about that hopefully towards the end, but it's definitely one of the key things that needs to be taken into consideration when building the lake. Data lake zones are another topic that's it's not the same. It's a little bit, sounds like environments, but it's different. So within a particular environment, let's just say within production, you're going to want to have different zones for your data. And these are typically divided according to sort of like these different levels. So there's different names for this, but some of the most popular is landing, raw zone, the clean or valid zone, refined, and then optionally you can have like what's called a secure zone or a sandbox zone. So typically the way this works is you have essentially different folders in your data lake or different zones, areas in your data lake where the data progresses from these first four. So the data comes in, maybe is landed. That's kind of the initial hop. And then it gets moved into raw. From the raw, it gets picked up and moved to valid or clean with some sort of light transformations and validations. And then typically gets sort of put into a standard format there. I'll talk about file formats in a minute. And then from there, that could be the last stage where it just kind of sits. But from there, you may pick it up again and kind of refine it by basically doing additional transformations. Those would be things that you would want to kind of have reuse across different applications. And then for data that's sensitive, you may want to have a separate zone basically to handle sensitive data. So personally identifiable data or data that for some reason the business deems is highly sensitive. And the secure zone would be useful for essentially having a kind of a firewall or a kind of area that's separate from the rest of the lake for access controls purpose. Finally, the sandbox is really a zone that's, this one's kind of a weird one, but it's essentially an area in the lake where users and especially data scientists can do things, can basically have write access. So they would typically, most users who are using the lake would only have read access to almost all these areas except for the sandbox. And the sandbox would be a place where users could actually, it's essentially like your home drive or your user drive on like a traditional Linux machine. So the sandbox is kind of fills that role, and it gives a space where people, data scientists and users can actually store stuff. Moving on. So data lake storage paradigms. The data lake has two primary storage paradigms, and this is a really important point that I want to just kind of take some time to talk through it, because it's actually one of the biggest issues I found in trying to deal with data lakes. So the two paradigms are essentially the hierarchical file system and the database, and they live side by side in the data lake. So part of the confusion is that most data lake systems use both of these at the same time, and these are essentially metaphors, right? These are just like the data lake metaphor. These are metaphors that are put on top of the data as a way of understanding and dealing with the data. And in some sense, they're kind of leaky. The metaphors are leaky because I'll say a leaky abstraction. That there are abstractions that are essentially leaky between them because the database and the hierarchical file system are both knowledgeable about each other in the data lake. And that's actually what causes kind of the problem, I think, a lot of times. The hierarchical file system is, you can kind of think of that as your big file system, right? If you look at your hard drive on your computer, you'll see files and folders. That's been around for years and years. The POSIX file standard is kind of the basis for that was developed back in the Unix days. And that's what Linux has used, and Windows has a variant of that, right? So that's what we're used to, and that's essentially what data lakes have adopted as kind of their underlying design for organizing files and folders. You can have typically in levels deep there, and it's based around this design called HDFS or Hadoop file system, which was originally designed after the Google file system paper. On the database side, there was a technology developed called Hive, which essentially created a database view on top of the file system. And it is organized into two levels, databases and tables. And it kind of is compatible with kind of your traditional SQL-based access. So the key point here is that having both of these models in place at the same time can be confusing. Typically what happens is you have like sort of a mapping here where the database is pointing to the file system, right? And you're defining tables. You're defining, I'll say, quote unquote, tables in your database down here, which are pointing to up here folders, right? So anyway, enough about that. But this is a key paradigm kind of mindset thing that you need to understand if you're dealing with data lakes. In terms of storage, there are some key kind of decisions that you need to make when you're architecting the lake. So data sets in a data lake are typically defined at a folder level instead of at the file level. So I think I already mentioned that. When we deal with traditionally with data, I guess kind of not in a big data environment, but just like in a file system, the data set is usually a file, right? But in the data lake, it's really a folder. Inside that folder will be multiple data sets usually with kind of arbitrary names that are randomly selected. So the folder becomes kind of the key thing to tie into. At the top level, there's typically a folder structure that aligns with the zones. So, you know, these different zones you'll essentially usually have like a top level folder for each one of these. There's also two kind of, this is just kind of one of the things that I've come up with over the years, but essentially there's two primary types of data to consider. And this is like kind of one of those things that I think is universally true in data systems. So I get a little bit of feedback. So if you guys can make sure you're on mute, I'm hearing a little audio. Two primary types of data. So event data and then reference data. So that's, you can kind of divide the world up into those two groups. Event data is essentially data that's coming in, like transactions, clicks, that kind of thing. There's usually always a date associated with it at some level. And it doesn't change, right? Once the data is fed in, it typically is immutable. So that's really the simplest and easiest type of data to deal with in any kind of system. The other type is really the reference or master or dimensional data, things like customer, product, et cetera. So that's data that actually changes over time. The attributes of that data changes. And you need to think about how are you going to capture those changes? How are you going to deal with them? And so a key point to deal with in data warehousing and data lakes as well is how are you going to store those changes? And really there's two approaches that I'm familiar with that I've used. One is snapshots. So you can just take a snapshot of that table every day or at some interval. And then you have that history of changes. Or the second is you capture the deltas. You capture the rows that changed, and then you store those deltas, and you might create like a slowly changing dimension type of approach there. So those are things that you definitely need to think about as you're architecting the storage layer. So file formats and compression. So important design choice is what file format you're going to use in the lake, and also how you're going to compress the data. Really for the raw zone or landing zone, the convention is kind of to keep the data in whatever format it's in. So that's fine. You can just land it there. Don't worry too much about it. Usually in the data lake world, you can process almost any type of format. But for subsequent zones, it really makes sense to conform it to a standard format that it's designed for the data lakes. So that which includes schema information. So basically, in these formats that I have listed here, like Parquet, Avro, or ORC, they all have built-in metadata into the file formats themselves, which makes it a lot easier really to deal with the data over time, and it's a great feature that just makes it simpler to handle and preserve the individual columns and metadata data types. So Parquet is probably one of the most popular formats for data lakes right now. It stores the data in a columnar format, which is great for analytics, and it compresses. It naturally has a lot of compression. In addition, you can actually a popular compression codec to use with that is Snappy. So that's essentially like it would be like a zip or gzip type of thing, but it's a more efficient compression for these big data workloads. Delta Lake uses Parquet. So it borrowed from that format. It didn't reinvent that, but it has some additional metadata that it sticks on top of it. ORC is an alternative format that's popular in Hadoop that's similar to Parquet actually in design. Avro is actually another popular format for streaming data. So if your data is not basically in large sets, the columnar format is really geared or designed for large sets of data. That can be compressed, whereas streaming data is typically single rows of data or single records. So Avro is actually used in Kafka a lot of times for that purpose, where it doesn't make sense to store it in large sets. I mean, over time the data will build up, but you can keep it in single files or single rows. One key thing is avoid CSV or plain text formats where possible. So that's kind of a lesson learned, but the efficiency kind of difference between these other formats and something like CSV is just night and day. I think it's like maybe 10 to 1 in terms of performance and size as well. So just try to avoid that. That's like the go-to format that everybody uses a lot of times, and it's kind of like the worst format for doing big data processing, I think. And then finally, consider whether the format is splittable. So that's a key consideration, especially for parallel processing, which is really the bread and butter of data lakes, is being able to split your data up and process it in parallel. And certain formats like CSV just may not be splittable, actually. So gzip is another compression codec that's not splittable. So if you have data that, and these are very popular and common formats that are in these non-splittable formats, the first thing you have to do really is process them on a single node in your cluster, or even outside of your big data cluster, and then send them into a format that can be splittable. So got a few more slides on this section. Data ingestion choices. So ingestion is the process of getting the data into the lake. When designing ingestion systems, there are many options and choices that need to be made. Basically frequency. So is your data going to be batch, micro batch, or streaming? ETL frameworks, you need to think about, are you going to go with kind of a GUI-based framework or code-based? Are you going to use notebooks? Are you going to have a metadata-driven solution? And push versus pull. So are you going to have data being pushed to the lake, or are you going to have actually pulling, from the source systems? So there's no necessarily right or wrong answers here. These are all just choices that need to be made. You need to be thinking about how you want to design, your intake of your. And by the way, ingestion seems to be the term for getting data into the lake. I used to hate that term, but I guess I've gotten over that. But sometimes, think of it kind of as indigestion when it gets bad. But anyway, data catalogs are also, I mentioned that earlier, is one of the key components. So this is increasingly becoming a big deal, especially in enterprises. You want to have a system to manage essentially your data and your metadata about your system. So this really manages more of the metadata, I would say, more so than the data, but it can have some sample data in there just to kind of show what the data looks like, but generally it's mostly just metadata. And so it has like definitions, columns, fields. It can have tags, especially things like the owner of the data sets, the classification of the data, whether or not the data has PII, personally identifiable information. It can identify things like subject matter experts. Modern catalog tools actually also have sort of features like crowdsourcing of metadata, which is really cool. And then even like things like gamification, where you get points, for doing things. And then some of the newer ones also have automated annotation. So I've listed some examples here. I personally don't have a ton of experience with a lot of these tools, but I've used a couple of them. On the last project I was on, we've actually used the Azure Data Catalog, and they just recently released, I think in the last couple of days, they released a new version of that called Purview, which is a new product I think it's going to be quite a bit better. I know on AWS you have Glue, and then Elation I've kind of seen, and that has a pretty impressive tool set. Hive Metastore. So, talking about the catalog, you can't really talk about the catalog without really touching on the Metastore. So I wanted to throw in a little bit of information about that. Basically, the Hive Metastore is an artifact from Hadoop. It was originally designed to kind of provide that database layer that I talked about earlier on top of the file system. And most data lakes today are still using the Hive Metastore kind of as their primary way of storing that metadata layer, that database layer that sits on top of the lake. So it's important to consider how you're going to provision your Metastore. If your architecture includes a Metastore, think about that. It's typically it is a relational database, and it can be provisioned in a variety of different technologies, including both open source and closed source. And some configurations allow you to have like kind of an external Metastore that's under your own control. So Databricks, for instance, allows you to do that. And you can, so like for instance, I'm using a SQL Server right now as my external Metastore. So that works well. It's just one of the things that's part of the architecture, and you need to think about it. Data lake consuming systems. So the lake will most likely host multiple consuming systems. And this is kind of a key point that you just got to think through. the implications of this stuff. So typically downstream from data lakes, you might have data warehouses or data marts. I mean, that they ideally, you should be feeding the data into the data lake, and then the data warehouse or the data mart is actually reading from the data lake. Operational data stores. So you may actually have applications or operational processes that are running from data that's being sourced from the lake. Feature stores, that's a fairly new topic, but essentially it's just a database that's specialized for machine learning, feature engineering, so that can be fed from the data lake. Data products or applications, so all kinds of applications could be running from the data lake, like dashboards, alerts, automated actions, or data sets. So some of the questions you need to be thinking about when you're designing data consumption will systems pull data from the lake, or will data be pushed? So that's actually something that we're dealing with right now, where I work is, we're trying to figure out which of these two patterns we want to kind of prefer. And really, I think ultimately you're probably going to have both. But how will the systems access the data? And then how will these systems be notified when the data is available? What environments will these systems be using for developing and testing, and which APIs will they be using? So there's a variety of questions that need to be answered. There's actually no simple answer for this in my mind. I think it's you got to work through the different alternatives and come up with choices that work for your environment. I would say try experiment with several and see which ones work for you. But there's no cut and dried solution, I don't think, right now for a lot of these things. And some of these may have to be developed as custom solutions. So I have a couple examples of modern data warehouse, and then I'll pause for questions if anybody has any. So this is I just pulled this slide from the web. This is reflective of kind of an Azure stack in Microsoft's cloud of what they call their modern data warehouse. So over on the left, you have kind of logs. This is kind of representing just to bring in different data sets or business applications here. Ingesting data, that they're using Azure Data Factory here is kind of an ingestion tool. So Data Factory can be used both for orchestration as well as actual data movement. So that's typically, that can be used. Azure Data Lake Storage is their storage resource type that they have for essentially the equivalent of like S3. And it's kind of a massively scalable, general purpose storage that supports kind of the HDFS APIs. Databricks, I mentioned earlier, is often used for, in this case, they're showing that for prep and training of models. It can also be used just as a general purpose compute processing. It can also be used for a lot of things. In here, they're showing Synapse. Azure Synapse is a fairly new product. Well, it's a rebranded product that they've had for a while, but they launched, I think, last year as Synapse. So they're using that. They're showing that here, how that can be tied in, and then Power BI. So that's kind of this is actually leaving out a lot of pieces. Other things that would need to be included here are probably things like, the Metastore itself is not reflected here. The Key Vault, the data catalog is not represented here, but those, there's a lot of little different resources that would probably be in here that need to be part of this to have the full picture. This is an example from Amazon. So I am not an Amazon expert by any means. I really have very little experience with it, but I've done reading on it and have done a little bit of hands-on with it. So this is from their solutions and implementation guides, and they actually have this as a kind of a nice. It's pretty cool. You can just actually click a button and deploy all this stuff in a few minutes as a solution. So they have up here at the top, you can see Amazon S3. That's their storage. Glue is kind of their catalog, as well as it basically ties in with the meta the orchestration, I believe, as well. And then ETL type functions. That's fairly feature rich in my from what I know. Then DynamoDB for database, Elasticsearch for I guess basically for searching, and then there's a variety of other services they have here tied into that. Lambda for processing. So like I said, I'm not the expert on this, but this is one view of kind of the Amazon or AWS approach for data lakes. But at the core really is the storage and then the compute here. EMR, Elastic MapReduce. I don't actually see that on their diagram here. Maybe I'm just missing it, but that would be kind of the other big piece of, that's essentially running a MapReduce or Hadoop type workloads against the storage. Okay, so I'll pause there before I get into the next section. Does anybody have any questions? No, I kind of flew through that material.
There's a couple questions in the chat.
Questions in the chat, David.
Okay. Let me see if I can find the chat. Or can you just read them to me?
Yeah, I can read them off. Okay, so for the slide about like batching versus micro batch versus or batch and micro batch, and then streaming, there's a question: why would you want batch or micro batch? I don't know the context of the question.
It's just really, kind of what your sources can provide. Ideally, everything would be streaming, but we're not really there yet. So until we get more systems kind of in that paradigm, or get access to, if you can get access to the data, then obviously, streaming would be better. But batching is a lot of times most systems are architected that way to provide the data like that. So it's until that's just kind of what the reality right now.
Okay, cool. And then the next two questions are from Prasad. The first one was around the time that you were talking about how CSV isn't good for a data lake storage format. He said, how about JSON file format? Good or bad?
It's okay, but I think it's again, Parquet or one of those other formats I mentioned is going to be more efficient overall, just because it's really designed for those kind of workloads. JSON, it's still going to have to parse the JSON line by line, and it just you lose some efficiency there. So I would say JSON's fine for your raw zone, but as you read it into the lake, I would definitely move it to one of the other formats as soon as you can to make it more efficient and faster.
Good to know. Last question, also from Prasad. How do you handle overlap between metadata catalog and the Hive Metastore?
You have to somehow manage that. So what we did was actually we built the Hive Metastore from the data catalog, and we had a sync process that did that. So we actually designed a process that would take the metadata from the catalog and then propagate that into the Hive Metastore. If you can't do that or something like that, then you just have to kind of manage it somehow, come up with a process that will keep them in sync. But it can be bi-directional. It would be nice if you could keep it unidirectional, but it may have to be a bi-directional sync process, which can be challenging. But yeah, it needs to be something to consider. It's probably one of the trickier areas, actually, of managing the lake.
All good questions. Cool. Okay, but
yeah,
that does it. Yeah, so you can continue.
So I see we're coming up on the hour, so I think I'm gonna just skip through these slides. I kind of just threw these in here to as something to think about, but I'll post the slides and you guys can take a look at them, but I won't go through it in detail. I just mentioned some of the topics here. So basically, when you're governing the lake, we need to think about things like security. That's obviously an important thing. So encryption and access controls. You need to think about keeping the lake available. So obviously things like backups and service level agreements are critical. Something that our team has definitely thought a lot about. Version control, resource locks, geo redundancy, automation. So all those are things that can definitely help to make sure that you keep your data available, your data lake up and running. And do you have a disaster recovery plan? Access patterns and roles. So just need to think through how you're going to give access to the lake. Systems, are one thing. Users are another thing. So they're different and they need to be handled differently. Regulations are a big thing. So there's lots of regulations out there, and we need to think through kind of what are the impacts of things like GDPR, CCPA, the California Consumer Protection Act. They now require you to tell your customers if you have data about them, and also give them the ability to ask you to delete your data. So that requires careful design and thought. It's a very complicated, thing that's introduced there. And I'll just put a side note there is Delta Lake really came to the rescue for CCPA. For us, it was, like that feature alone allowed us to enable that. User support. So we've kind of touched on that already, but make sure that you're thinking through how are you going to support users, data catalog, access, training. I mean, that's often kind of a side thought, but users need to understand how to use these new tools that you're sending up. Sandbox provisioning can be a big thing. So sometimes you might even have a whole team dedicated to dealing with stuff like that. And then support. Technical exploration is also a big thing. So as we get into these new technologies, we need to think about how are we going to explore different tools. The main things there are we need to go out and try different tools, but we also need to minimize the number of tools that we're supporting. So we need to have some sort of process to choose and narrow down the list of tools and consider the total cost of ownership. So having a dozen different tools that do similar things is not a scalable way of maintaining an organization. Performance tuning is also a big thing to think about. So there's lots of could go deep into that, but essentially, maintaining the health of the platform, we need to make sure that the jobs and the things that are running on it are not getting into issues like skew or cache, or just jobs not running efficiently. Lessons learned. So I'll just kind of breeze through these. So first of all, managing environments is hard. So I already kind of mentioned that keeping environments in sync. That's been I don't really have a great answer to that. When I do, maybe I'll come back and give another talk on that. Automate everything. So again, kind of talking about the disaster recovery, being able to kind of go back and redeploy everything from automation is huge, and also just moving between environments. So kind of going hand in hand with managing environments. Automation is your friend. So if you can try to from the get-go automate all the stuff. Don't rush to fill your lake, or you might wind up with a swamp. This bit us on the first project I was on. There was a big push to kind of fill the lake, and it just wound up with a bunch of stuff. So a bunch of data that ended up really not being that useful. So I think it's actually okay to slow down a little bit and be intentional, if you can, about how you're bringing data in, what data sets you want to fill the lake with, and make sure that you're capturing, so know your data. Kind of as the next point, like as you bring in data, try to spend time up front understanding the data and capturing the metadata about it and putting that into your catalog. Pick a high value use case and to demonstrate value quickly. This is kind of a no-brainer, but for projects, especially if you're starting from scratch, you want to deliver value. So it's good in every project I've been on. One of the good things we did was we actually had high value use case that we were able to demonstrate value to the business and kind of return on the investment for the cost. Minimize complexity. So this is always important in big projects, especially. But if you can, just try to cut down on the number of things that you have in your environment. Like just keep it as simple as possible. Make sure you have backups. I won't say much about that other than it's important to have backups. Let's leave it at that. Enable self-service. So this is kind of a key thing, is just to have data scientists and users be able to go in and do things in the lake themselves. It really just frees them up to do things that they wouldn't be able to do normally, and it's just a critical component. But set limits and controls on the user space. So with the self-service comes responsibility, and we need to have some sort of limits and controls so that they don't just kind of fill up their user space or their sandbox area with a lot of data that is not governed or controlled. And finally, try out different options, but settle on a single solution. So if you can, as you're exploring, yeah, it's great to go out and have 3 different or 5 different tools that do something similar and do a horse race. But at the end of that, try to pick one and consolidate to a single solution that you can support. So what's next? I'll just touch on these and then I'll be done. So machine learning and AI, that's kind of this is obviously not really new. Obviously, it's been around for a long time, but increasingly, this is really the data lake should not be an end of itself, but instead should really be an enabler or platform for doing some of these things. So I already talked about feature stores. That's a key thing that's we're seeing more and more of, and then model registries. That's another key architectural thing. So probably somebody could give a talk on those 2 things, or those could be 2 separate talks, but it would be interesting to hear more about that. But there's so much potential in artificial intelligence that it's kind of mind-blowing what can be done there. The Lakehouse is a new thing that has just come out recently, I think this past year, from Databricks. It's going back to the whole metaphor thing. It's a new metaphor that they've introduced. I don't know if it's going to stick, but we'll see. But it's essentially combining the concepts of data warehouse and data lake. And they're claiming that you can use their technology stack to essentially have a single lake that serves as kind of a warehouse as well. And then event streaming platform. This is something that I'm actually a big fan of. This is championed by Confluent. Jay Krebs is creator of Kafka, has talked a lot about this. So the idea is you have kind of an event stream hub and spoke architecture where all the systems stream in their events, and then they read from that hub. So including the data lake here. So the data lake could be essentially just one of the spokes off of this hub, but the idea is you have everything flowing through kind of this streaming platform using something like Kafka, and it really enables a lot of things that aren't possible otherwise. And then this book, I actually read this book to kind of help me prepare for this talk. I recommend it. It's a good basic overview of a lot of the stuff that I talked about, but if you want to go deeper, it's a decent read, and I'd recommend it. And that's it. I think I got in just about an hour. So, any last questions?
There's one more that popped up in the chat. One last one from Prasad. Prasad, if you're here, you can just ask it if you want. Otherwise, I will. Okay, I'll go for it. All right, so Prasad asks, if most data is structured, then is it better to load raw into Synapse and then process there to load into dimensional schema instead of Lake and Spark processing? Gonna embed one more person in here. Instead of Lake and Spark processing, why choose one? Why would one choose the latter, I guess, instead of Lake and Spark processing?
I'm not sure I understand that question.
Yeah, do you want to open the chat and take a look yourself?
Yeah, I actually, I'm not seeing the chat window. I'm not sure why.
Should be right at the bottom, next to the share screen button.
Okay. Let me stop here. Yeah, I'm not seeing it for some reason. I don't know if I did something to my screen and it just went away. So.
All right. Well, here.
Hey, David, are you able to hear me?
Hey, Prasad.
Hey.
Yeah,
David.
Can you repeat your question?
Sure. I had some issues with my audio. Couldn't figure it out just in time now. I was kind of playing some devil's advocate. So the idea here is like bring data into the lake, process there, load it into feature marts or stores, design data stores, right?
Okay.
Like Synapse, Teradata, right? But instead of doing that, if all or most of the data is structured anyway, then why not just bring it to tools like Synapse, process it there using familiar T-SQL type languages, and just generate dimensions and facts and that kind of schema there itself.
I mean,
and bypass the lake altogether.
Yeah, that's definitely a pattern. And one of the projects I worked on, in fact, we built a lake essentially in a database lake, right? So I think that's possible. It's you lose some of the benefits of having the flexibility of kind of like the file system metaphor, right? You're dealing, in that case, you're just dealing with the database, and you're dealing with the data lake as a database only. So having that file system paradigm is kind of one of the things that is a benefit of the data lake architecture, where you can have a lot of flexibility in terms of how you're storing the data in different formats and so forth. And I guess it's just a big file system, right? So you can kind of think of it just as unlimited file store that can pile up forever, whereas a database is typically has some limits and is typically a little bit more expensive from a storage perspective. But that said, like the way the lines are blurring between these technologies more and more, and I think that we're seeing crossover. Like each of these technology stacks, like Synapse is blurring the line between a database or data warehouse and like a data lake too. In fact, I would kind of say Synapse is becoming like a Lakehouse almost architecture in some ways. So I think the lines are blurring, and like this whole Lakehouse paradigm may end up being a thing where it's more you don't necessarily have to have either or. You can have both.
Okay. Yeah.
Yeah. Good question. I don't think there's any right or wrong answer there, but I think that really is where do you want to store your data long term? Do you want to have it in a kind of a file system that's somewhat flexible, or do you want to have it in a kind of more structured database storage?
Yep, sounds good. Thank you.
Anybody else?
Yeah, it looks like there's one more question. Christian Hansen says, thoughts about CCPA? It really changes whether you save raw data or you have to lift into something that can support CCPA.
Yeah, that's a great question, Christian. I appreciate that. What we ended up having, I forgot to add, I meant to add a slide on that. I had too many slides already, but data retention is actually the key thing there. So what is your retention policy? And you need to think about that, right? So in this case, if it's CCPA related, like, so the California Consumer Protection Act basically says that if somebody from California calls you up, you have a customer, they can ask for their data to be deleted or to be disclosed. The deletion part is the tricky part for a data lake. So what we have to do there really is say, okay, if since we're moving in this case, we're moving the data from raw to valid, and valid is storing it in the, let's just say, Delta Lake format, that gives us the ability to do updates, like I mentioned. But the raw data would typically not be in that format. So in that case, what we've decided to do is just keep the raw for only 30 days, and that allows us to keep within the time frames of the compliance with the CCPA. So ultimately the raw data is no longer kept forever. It's essentially only the valid data, and that's kind of a compromise solution, but it worked in that case. So that's an answer, but yeah, it is definitely a consideration. How do you deal with raw data in light of those regulations?
All right, it looks like we have one more question from Ashley Smith. Does streaming affect the data lake architecture, or is it handled the same way as batch processing?
So depending on what tools you're using, the data lake can definitely handle streaming data, and there's several different. That's a whole other topic really, but like there's Kappa and Lambda architecture was the first one that sort of popularized that bimodal model of having streaming and batch. And then Kappa architecture, which is sort of based around the Kafka thing, consolidated that. But The short answer is, yeah, you can definitely support that in the data lake, and Databricks, for instance, supports both of those really nicely using the same basic API. I mean, similar API. So they have a data frame API and they have something called structured streaming, where you can kind of use the same code in both paradigms. So you can support reading streaming files or streaming data sets the same way you would read batch data sets.
Cool. Well, I think that pretty much does it for
yeah
questions.
Great questions. Thank you guys for listening.
Yeah, this has been a great talk. Thank you so much for putting this together, David, and closing out the year for us.
Guess we can wrap it up. Stop the recording, Sam.
Yeah.